Okay, we're now ready to do a forward and backwards pass. Just a reminder that with CPM, you only have a single estimate of time, usually the most likely estimate, and you would just use that time to do your forward and backward pass. With PERT, we add a level of sophistication to it and a higher degree of accuracy in that we give you the range of times for each activity. But of course, you have to convert those into an expected or calculated time, and we showed you how to do that in the earlier video. So I'm going to use this expected time that we figured out using PERT. With CPM, as I mentioned, you will only have one set of time. And so looking at the diagram, we can determine what the early start is and then calculate the early finish. And this is the forward pass. So activity A and B don't have anything at the preceding it. So both these can start immediately. So they can start in the 0 week. And so we'll put that in for activity A and B. The earliest we'll be finished with activity A is that it takes us 2 weeks based on our calculated or expected time. So the earliest we'll finish it is 2 weeks later. So 0 plus 2 is 2. For activity B, it takes 3 weeks. So 0 plus 3 is 3. Now here's where we have to look. So if we were to go on and do activity C, it says that A has to be done before you can do C. Well, A is done in week 2, so we know that's the earliest we can start activity C. So we'll put a 2 there. We add to it the expected time or the calculated time given us. That is then 4. 2 plus 2 is 4. Let's go to D here. Now D is interesting in that both A and B have to be done. So A and B have to be done. So we got a 2 and a 3. Remember on your forward pass you use the higher of the multiple nodes. So if you have 2 or more nodes going to this node, then you use the higher of them because all of the activities have to be done. So if we were to use a 2, well then that wouldn't make sense because activity B is not done yet. But if we use the 3, then we know that activity A and B are both done. So the earliest we can start D is 3. And then of course the time that we expect activity D to take, that is a 7. Let's continue forward. E, it just has the C, so we'll look at when C's finished. C's finished at 4. And so we'll add on to that the 4, so we're up to 8 there as the earliest finish. So we can start in week 4, it takes 4 weeks, it gives us a finish of 8. F also can be started after C. So C was 4 when it was finished. We're going to add to that the 3 weeks, so that's 7. G takes D and E, so once again we have 2 activities. So we'll look at D and E. D is finished at 7 weeks, and E is finished at 8 weeks. So we're going to use the 8 because then both D and E will be done. 8 plus 5 gives us 13, and then we're at H, and once again we have G and F. So we'll look at G and F, 7 and 13. We'll use the higher of those, 13 plus, so we wind up with 15. So this is nice in that there's a single finishing point. If there were multiple finishing points, you would have to find what the greatest number is. And that is your forward pass. So we know that this project will take 15 weeks. And so we're going to now work backwards and do our backwards pass. So we'll put that in once we know the final end of the project. So if you had more than one ending point, you would have to determine what the max is and then set all of those ending points equal to that maximum number. And then we can do our backwards pass. So we only have one ending point, so we're going to set it at 15, and we're going to work backwards, and we're going to subtract then the expected time. So working backwards, we're going to go from a late finish to a late start. So if we take 15 and subtract the 2 weeks it takes to do H, we're at 13. Going on to G. G, the latest it can finish is 13 because the late start for H is 13. So look at the relationship you have here. So we're trying to figure out the latest finish. Well, it has to match the latest start of the one that follows it, but we're working backwards. So we have this late start of 13, so G has to be done by 13 so that we can do H. So we're going to put that in for there, 13. We'll also do that for F is 13. We'll subtract then the expected time. This will give us an 8. So 13 minus 5 weeks. The latest we can start that is week 8. This one would give us 13 minus 3 would give us 10. And then we can move on. So E, you got G. So the late start for G is 8. So that becomes the late finish for E. And we'll subtract then the time that it takes. So that puts us down to 4. D is also off of G. So we said that was 8. And the late start for G was late, so the late finish for D has to be 8. And we'll subtract the 4. That gives us 4 here. And then we go to C. C, here we have 2. We have F and E. So we got to look at F and E. F and E is 10 and 4. Now remember, we're working backwards. When we were doing forward, we took the highest of the numbers. When you're working backwards, you take the lower of the numbers because you don't want to delay the project. So we can't really do 10 as a late finish. We have to do 4 as a late finish for C. So we'll put 4 there. We'll subtract the 2 weeks of that activity. Now we're back to B. B has D. So we'll look at the late start for D is 4. So this becomes a 4. And this one becomes then 3 becomes a 1. Here we have this again where C and D working backwards. C and D, so we got to look at the late start for C and D is a 2 and a 4. So remember, when you're working backwards, use the smaller of those numbers. That becomes the late finish is 2. And then, of course, then we subtract the time. And so that gets us back to 0. Now, here's where it's helpful sometimes to have a single ending point to double check that you did your calculations right. You have B and A. But we would go with the smaller of those, so that was 0, so we're back to 0. If we did not wind up with a 0 on A or B, then we knew we did an error in our calculations. So now all you have to do is compare the starts or the finishes. So we'll do starts, and I always do finishes as well, just so I can double check that I did my calculations right, because they'll give us the same answer. So let's then calculate this out. We'll take the late start and we'll subtract the early start. Let's copy that down. And then we'll do the late finish minus the early finish and copy that one down then. And basically, where you have zeros, that means they're on the critical path. This should make sense because think about it this way too. Activity B has a slack time of 1, and you'll see that no matter whether we compare the starts or finishes, it's the same. It won't ever give you different answers if you did your calculations right. Because what we're saying is B could start immediately, or you could wait a week and start it, and it won't delay the project. The earliest it can start and the latest it can start are different. Or the earliest it can be finished is in 3 weeks, but we could also, the latest we could finish it is 4 weeks. So we have an extra week in there. Probably the most dramatic is this one, activity F. we can start it as soon as week 4, but we could wait all the way until week 10 and start it and still get it done on time. Or vice versa, you could finish it in week 7, or you could wait all the way until week 13, and that would not delay the project. So we want the slack time. So in this case, the critical path is A, C, E, G, H is our critical path through there. These are the ones that are going to dictate, because they have no slack time, whether you compare the starts or finishes. And so those are the ones we want to concentrate on when we do further analysis using PERT. And I'll come back and talk about that in the final video.